My name is Laura Ashley. I will be hosting today's event. First, I want to talk about the Center for Excellence in Education. We are a Virginia-based nonprofit organization that was founded in 1983 by Joanne DeGennaro and Admiral Rickover, who is father of the nuclear navy and civilian uses of nuclear power. Our center has a mission to nurture high school and university students to careers of excellence and leadership in STEM. Here you can see some of our programs. We have the Research Science Institute. We have the U.S. Bio-Olympiad, the Teacher Enrichment Program, which is the program that's sponsoring today's event, and our new program, STEM Lyceums. If you are interested in the chat, there are links to each of the programs on our website so you can learn more about them. So once again, I want to thank our panelists for taking the time out of their day to speak with us about what they do, and for the college representatives to tell us a little bit more about their college and their opportunities for students. Our industry speakers that I'll introduce today are Mia Jackson and Roger Salway. Mia Jackson is the Chief Executive Officer at Vital Care Industries, which is a healthcare supply business. She graduated from UCLA with a bachelor's degree in biomedical engineering and also has an MBA and a Master of Science in Engineering Management from Northwestern University. Mia has worked in engineering consulting and supply chain operations. I also am pleased to welcome Roger Salway. He is the Economic Development Coordinator for the town of North Branford, Connecticut. He graduated from University of Manchester Institute of Science and Technology in England with a master's degree in electrical engineering, and has worked in manufacturing industry as a manager for many companies, including Procter & Gamble, Booz Allen and Hamilton, and John Deere. In his role as Economic Development Coordinator, Roger has recently received recognition as a top-level economic development practitioner in the state of Connecticut. I'm also pleased to welcome our two representatives from local West Virginia colleges and universities. We have Danielle Linsenbigler, who is Assistant Director of Admissions at West Virginia University. And we also have Brian Bucklew, who is Academic Counselor at Eastern West Virginia Community and Technical College. So they will be talking with us about their college, university, and the programs for manufacturing that are offered there. So first, I will turn things over to Mia Jackson, who will share with us about her STEM journey and a little bit about what she does in manufacturing.
Hello, everyone. Just wanted to share a little bit about my journey and answer any questions that you guys may have towards the end. But to give you a little bit of background, and Laura, thank you for the intro. I started my career or college degree in engineering. So technically it's a chemical engineering degree with a biomedical option. I actually participated in an RSI program between my junior and senior year of high school. It was an amazing program, hanging out in MIT and doing research there, and it was a great summer. So I definitely highly recommend it for those that are interested in kind of an immersion research program. Leaving from high school, I went to UCLA and majored in engineering. I selected engineering, one, because it was one of the most flexible disciplines. It would allow me to really learn some problem solving skills, but also allow me to utilize the passion that I had for math and science. And I always was curious about how things worked. And engineering is a great discipline to be able to figure that out. From there, I actually thought I was going to go and become a doctor. And I decided that I didn't want to go into medicine. And then I thought about research. And I actually decided to go and, upon graduating, decided to go into industry. Although I have a biomedical engineering focused degree, I actually went and got a job at a building supplies company, manufacturing company. So if you guys are familiar with the pink insulation that goes behind your drywall, I made that with Owens and Corning, their plants out in a little bit south of Atlanta, Georgia. So I did that right out of school. And that was my first kind of full-time job. And I had been familiar with manufacturing. I actually worked for P&G in their paper and towel plant in Oxnard, California. And again, similar to engineering, manufacturing is making stuff. And that was really intriguing because there's a lot of aspects that you can really dive into when you're manufacturing. There is just the process itself, learning how to optimize that process, because there's always ways to make it go faster, more efficient, less waste. And additionally, there's the cost aspect too. And then there's the people aspect, because a lot of manufacturing, you need to have people that run things. And so throughout my career, I have really focused on those three areas and really honing my skills and my knowledge in those areas. Initially, I started off with growing and understanding the process part. I don't know if you guys have ever been familiar with something called Lean Six Sigma. At Owens Corning, I really dove deep into Lean Six Sigma and really got a certification and really learned how to apply that to all aspects. And then from there, I took that and I went to business school at Kellogg in Northwestern. I also got a master's in engineering management at the same time. And I knew that I wanted to transition out from just kind of the engineering focus and kind of process focus. And I want to marry that with kind of more top line management. I think originally I thought I was going to be a plant manager. And after business school, I set my sights a little bit higher than that. And I actually wanted to go and own my own company. And that started that journey. Outside of right after Kellogg, I actually went into consulting, which I think is a great way to get exposure to different industries. It also allows you to take the problem solving skills that you would learn from STEM and apply that to different types of settings in possibly different types of industries and functions. Consulting also allowed me to now get experience, not only just in manufacturing specifically, but in different aspects of a total business, right? What are the impacts? So like I mentioned before, you have the people aspects of the human capital. You always need people in order to be successful in anything, and you need to get people to be inspired and want to come to work and give their all. But you also need to make sure that you're providing a safe environment for them as well. And additionally, you need to make sure you're doing it all profitably, right? You can't, it's hard to run a business or whatever you may own, whether it's a small department or a small section of a manufacturing line, whatever it is, you want to make sure that you take pride in running it efficiently, but also profitably, right? And so that means that you don't want to waste either your time, you don't want to waste products or raw materials. The idea is you want to be able to increase the profitability of a particular product. And that's kind of the bottom line to any business, right? You're always looking to, whether you have a service or a product, you're looking to maximize your profitability year over year. So picking up kind of career journey, it seems like it's long, but career journey. So I did consulting. I led my own consulting firm for about 4 or 5 years. Again, getting this breadth of knowledge. I actually advise a lot of CEOs and preparing for their companies for sale. Additionally, of helping them increase their profitability, whether that be growing sales or also cutting costs by improving processes and procedures. I essentially went to, and I did what's called a search fund. And that's basically, I'm partnered with a private equity firm to buy a company. And so I did that search for 2 years. I essentially identified a company and acquired that company along with my private equity partners in December of 2020. And that company is Vital Care Industries. We manufacture medical surgical supplies. So think about if you're ever in the operating room, you need to cover the patient to maintain a sterile field, but you also need to cover all the equipment in the operating room to maintain a sterile field. And my company manufactures and distributes those equipment drapes. We also have solidifier. You think about all the things that come out of the body during an operating procedure. Those things have that liquid, that biohazard liquid needs to be in a solid state or more like a jello-like state to be transported. And so we sell a product called Absolute Solidifier. And then we have one with a treatment that actually kills all the pathogens and allows the operating tech to throw that into the regular trash can. We also sell sterilization packaging and dust and cart covers. And so my company, as I mentioned, manufactures. So we actually have a plant in Vietnam. We also have another small light manufacturing plant in Arizona, and we're headquartered in Chicago, right outside of Chicago, Illinois. So, I believe that all those things, including my even high school, the knowledge that I learned in high school and my immersion and career path in STEM has brought me to this point. Taking all of the technical and marrying that with the MBA has allowed me to kind of be equipped to ultimately manage a company, and more specifically a manufacturing company. We're in the healthcare industry, and I have a biomedical engineering degree, and I had a decent amount of experience in the healthcare, but essentially, Vital Care is a manufacturing and distribution company. And so those skills that I had, that I learned in school, that I had in my internships and work balance, work life, I was also able to bring to my current role as CEO. So I will stop there. I do believe you guys will have a Q&A option towards the end, and really looking forward to any questions that you may have, and hopefully that I can answer. And hopefully this was helpful to you, hearing my journey, and inspire you to blaze your own trail and utilize STEM to do that.
Thank you so much, Mia. That was great. It definitely seems like you have a lot of overlap. Like you said, the interdisciplinary nature of STEM, your background in college allowed you to, gave you the background knowledge you needed for your manufacturing career. So that sounds really cool. So now I'm going to turn things over to Roger Salway, who is going to share more with us about his manufacturing journey.
Yeah, that was tremendous. Let me just give a little bit of background. I was born in England, as you could probably tell from the accent. I did my master's degree in electrical engineering and joined Procter & Gamble in their executive development program. And we worked directly with a consulting company called Booz Allen and Hamilton that some of you may know. And in the course of that, we were looking at expanding Procter & Gamble in Europe, which I got involved in. And Booz Allen then said, why don't you come and join us and kind of see the world? So I joined Booz Allen, based out of the London office, but I was also working out of the Chicago and Paris office. So one of Booz Allen's clients was a little company called John Deere, that you may know in Illinois. And we did a major assignment that I directed with John Deere, and I commuted across the Atlantic for 18 months every other weekend. It was kind of crazy. When we finished the project, which was a major sort of manufacturing technology project for Deere, Deere said, why don't you come and live in the States? And you may know Illinois has got a little town called Moline, which is about 2 hours or 3 hours west of Chicago there. And so I transported myself and my wife from downtown London to little Moline in Illinois, and became director of worldwide product support. So that's the whole supply chain logistics for Deere around the world, which was kind of fascinating. Having done that, Deere said, why don't you go back to Europe and run us? So I became general manager of Deere for Europe and Africa and for Asia as far as India. So that put me out of engineering and out of manufacturing into general management. Deere then dragged me back again. And so we had houses now in Brussels and in England and in Moline and I became director of new business ventures worldwide for Deere. So did joint ventures in China and India and all kinds of places. Ultimately left Deere and became the CEO of a manufacturing company that was one of Deere's major suppliers, and turned that around and we sold it. Essentially, I kind of took the opportunity at that point to retire and get into nonprofit work, which is where I met Como, who you met, I think, Joanne or LA, and did a whole bunch of agricultural sort of mechanization and productivity improvement work across Africa and in parts of Asia. Then my two kids both moved to New York. So I said, you know, why be in New York? So my son, by the way, is the senior director of New York City Hospital System. So very much involved, as you can imagine, in all kinds of supplies. So we moved to New York, and my neighbor is the chair of the State Senate Engineering and Technology Committee at the headquarters in Hartford. And we got meeting, and he said, you know, why are you retired? We could use you. Okay. So I kind of unretired, and partly now I am part-time, and I'm working directly with the Commissioner for Economic Development for the state of Connecticut in this little small town. The small town is important in the sense that it's become a manufacturing cluster, and it's strictly advanced manufacturing. We have now added 1,000 jobs here in the last 3 years that I've been here. Honeywell is a major employer, and most of it is essentially how do we get our school system and our community colleges to kind of catch up with the needs of advanced manufacturing. So that's kind of my background. I would like to see if the work that we've done in Connecticut is in any way of any use to the teachers and community colleges in West Virginia. I'm not trying to preach that Connecticut is ideal, but when you look at the gross domestic product and the number of people engaged in manufacturing, we have 3 times more people working in manufacturing in our little small state than there is in West Virginia. And our GDP reflects that. So maybe we can help in some way to expand manufacturing in West Virginia. So with that, I'll just quickly turn it back to LA and just run through. Okay, you can see what it's all about, making stuff. Okay. And the next one, please, LA. So here in Connecticut, a guy called Eli Whitney, you probably heard of Pratt & Whitney, and make aircraft engines. He was a mechanic. He was not a particularly kind of bookish kind of person. At 14, he built his own Fords, and he actually kind of built things for Yale. And he essentially became the kind of promoter of STEM in his own way at that point in the 1800s. And now Pratt & Whitney, of course, is a worldwide company. Okay. So some quick facts. We have 160,000 people working in manufacturing. That compares with about 50,000 in West Virginia. So you can see it's like 3 times as many people. And just some idea of what that does to the amount of money being spent on investment in capital in manufacturing facilities. We export 17 trillion. We add that much to the Connecticut GS great domestic product. But the interesting thing, each time you create a job in manufacturing, typically you create like 3.5 other jobs. Everything from janitary supplies to all kinds of tooling and support services. So creating jobs in manufacturing creates a lot of other jobs. Okay. Thank you. So as you can see, we are the Silicon Valley of advanced manufacturing, according to our governor, and I guess I have to believe him. We are very innovative, and partly because we've created a system for young students to move through community colleges and into, we have, as you know, a couple of colleges, which we'll talk about in a little bit, that focus on advanced manufacturing education. Okay. So this is the kind of progression. Some of you may have seen this. Kind of manufacturing 1.0 was early mechanization, steam engines, started mostly in Europe, progressed to mass production that became more involved with obviously North America and then Japan. Now it's into automation, IT and electronics. you get into 4.0, where unfortunately at this point, China is in the lead. So it's really important for us to start looking at how we catch up and close the gap. I won't spend time, but here are some of the things that are part of advanced manufacturing. So we have some schools just nearby that have adopted advanced manufacturing technology centers within their high school. Any of these schools are happy to share with anybody interested their programs, and I can connect you. You can see the kind of facilities. They've got CNC machining, they've got 3D printing. We're doing engineering career development in another school. So these are just one, and you can see at the bottom, we're doing career days in middle schools and high schools with Board of Educations in a number of towns. And this slide is a little out of date now. There's about 12 schools, high schools primarily in the state, that are now offering advanced manufacturing education. Okay. And we're doing a program through community colleges, a very short-term program called Skill Up for Manufacturing, where we are taking essentially unemployed and underemployed personnel and giving them a short program covering some of those topics you can see. And it actually starts to create pathways into the local manufacturers. And again, that program we could happily share with anyone interested. And here's some community colleges that are nearby that are doing advanced manufacturing and manufacturing engineering technology as well. So again, I don't want to just labor the point that these are in Connecticut, but they are colleges that have developed programs. And obviously, if we can avoid having to reinvent those things by sharing, we'd be happy to do that. It leads to innovation. And as you can see, we're perceived to be, after California and Massachusetts and the state of Washington, the next most innovative economy in the country, which is kind of flattering to know such a small state can actually be creating so many things. So we have innovation summits at Yale, day-long events, and we encourage innovators. We set up incubator technology centers in New Haven. And the University of Connecticut has built up a tech park. Again, you can see some of the things they're doing there. I don't want to labor that, but again, it's an opportunity to connect you with any of these kind of centers of progress in technical education. That's just a list, so take the time, read through that. If any of those look of interest, please contact me, probably through LA, and then we can connect you with any of those things. You can see there's manufacturing innovation funds, which we've created through the Economic Development Center of the state. We built up apprenticeships. We have the Center for Advanced Technology, which runs courses for educators all the time. We have a kind of consulting group called Constep, which helps business grow and improve. And I just mentioned earlier the Skill Up for Manufacturing. So these are all kind of internal services that are available, and happy to connect you with the people running those programs. And there's just a few of the careers that are available in manufacturing. And as you can see, some of them, even in John Deere, for example, I was director of sales and marketing for Europe, but having a technical background had a huge plus in sales and marketing. So you can see quality assurance, supply chain, information technology, and obviously engineering, and just operations, just running things. So that's about it. I think my 15 minutes is up, Anna.
Thank you, Roger. It definitely seems like your career in manufacturing has allowed you to travel all over the place. That has been really cool.
It's good not to be traveling at the moment.
Yeah. All right. Thank you, Roger. We'll come back for Q&A at the end. I would like to take this time now to turn things over to Danielle Linsenbigler, who will talk to us about manufacturing at West Virginia University.
Definitely very thankful to have this opportunity to talk a little bit about the programs that West Virginia University offers. Now, just kind of as a general overview, these are all of the different schools and colleges that we have. You're going to find STEM really intertwined in all of them in some way, shape, or form. We're going to focus on some of our larger ones today, a little bit more prominent in the STEM fields, but again, this just gives you an idea of what we are able to offer. If anything that we discussed today you want to learn more about, we have a really really interactive website where you can go to learn more about the programs. You can actually see a projected plan of study, so learn a little bit more about the courses that you would be taking as a student in that major as well. So probably the program that we think a lot of when we hear STEM is our engineering, and that is definitely one of our strongest programs on campus. We have a lot of different disciplines, everything from aerospace to cybersecurity, petroleum and natural gas, and in between. Engineering really prides itself in being very hands-on, offering a lot of experiential learning opportunities for students. So not just learning in the classroom from a book, you're obviously going to do that as a foundation, but then going out and actually bringing what you're learning to life. We also offer some really unique dual degree programs that allow students to graduate with 2 engineering degrees instead of 1. Probably the most popular dual degree program that we see is the mechanical and aerospace. And so again, just gives students a lot of opportunities to really dive into the specific field of engineering that they are interested in. Now, if you don't know the specific field of engineering, you know that you just like, creative problem solving, team building, that science, math, curriculum, you don't have to know right away. So your first year is a common curriculum, and then your second year is when you would actually declare that field for engineering. So some of our other STEM programs, everything from animal and nutritional sciences to mathematics. And you can see the example there. A lot of our programs then give you the opportunity to dive a little deeper through areas of emphasis. So for example, within mathematics, you would major in math, but then can pursue everything from actuarial sciences to physical applied math, pure mathematics, a lot of math that is well beyond my scope, but you can definitely do that within areas of emphasis. Forensic science, we have one of the best forensic science programs in the entire country, largest crime scene training complex of any college or university right on our campus. So a lot of really cool opportunities within that field as well. Then we do also offer, we have a medical school, and so a lot of great pathways to get into that program. And so if you're interested in medical school, that's not a one-size-fits-all for your bachelor's degree. It's based on your interest, your areas of strength. So everything from biochemistry to neuroscience, exercise physiology are all going to be able to get you into that pathway. We also have an office, it's a pre-health professional development office that is going to help you no matter which one of those options you choose to make sure that when it does become time to apply to medical school, you are as competitive as possible. We also have an undergraduate research office, and that's something I think that really sets us apart is the opportunities that our undergraduate students have for research. We are classified as R1, which is the highest research classification, and we have opportunities for students to be published as undergraduate students. We have a research apprenticeship program that helps pair you with people on campus that are conducting research in fields of your interest. And we have research symposiums where our undergraduate students get to show off their research twice a year. We also have a lot of programs in the natural sciences and agriculture. So if the environment is something that you are passionate about, there are a lot of STEM programs that can help you pursue that field. Environmental geoscience, environmental and community planning, agribusiness management, the list goes on, you can see that there. And so what I think is really nice about WVU is, again, we have some of, those more traditional, but you automatically think of when you think of STEM and manufacturing, but then we have a lot of really unique programs that allow you to explore some interests even further. Healthcare, I mentioned that we do have a medical school, but there's a lot of other options to go into healthcare that don't involve going on to medical school. So dental hygiene, music therapy, art therapy. I mentioned that STEM is really intertwined in all of our colleges. So even our College of Creative Arts have opportunities for you. Nursing, public health, sport and exercise psychology. So again, you can see a lot of different avenues based on your strengths in those STEM areas. Graduate programs in healthcare, aside from our medical school, pharmacy, a lot of students don't realize the level of chemistry that's involved in a pharmacy curriculum, physical therapy, so many more. So you can really pursue, again, any interest that you might have. And again, I know we'll do questions at the end or in the Q&A portion of the Zoom, but again, you can go to that website to learn more about any of the academic programs that we offer. So again, thank you for this opportunity.
Thank you, Danielle. I'm so glad you mentioned chemistry too in pharmacy. I used to teach chemistry and I would tell my students all the time, and they would ask, when am I going to use this? You know, you are using chemistry in pharmacy. So appreciate you sharing that.
Absolutely. Thank you.
All right. So we're going to turn things over to Brian Buslew, who will tell us more about Eastern West Virginia Community and Technical College.
All right. Thank you. And hello, everyone. I hope everyone is very well today. First few things about myself. I was a non-traditional student, went back to school when I was 35 years old. Before that, I worked in the manufacturing field for a cabinet company for many, many years, and saw several advancements in those years that I was there. And it seemed like it was about every year something new was replacing something already new. That's just how fast technology moves anymore. And then I came here when I was about 35 and got my degree in technical writing, which is another in-demand field in the STEM field. So I'm sure that, most of us know that the focus of STEM fields is not something that's new. Even in 1862 with the Morrill Act, it came through to promote agricultural science. And that's something that we have here at Eastern West Virginia University, or Eastern West Virginia Community and Technical College, I'm sorry. And, we promote the agricultural sciences as well. We have agribusiness programs to go along with that. And of course, in the 1950s, there was a response to focus again on STEM technologies because to respond to Soviet advancements. And then in 2001, STEM focus came up again, this time with diversity in mind, which is something that absolutely is vitally important for STEM related fields because scientific progression is created by diverse minds and experiences. Now here at West Virginia, we are Eastern West Virginia Community Technical College. We have we are a very inclusive school. At least we try to be as much as possible. It is a very small school in a very rural area, but we do have some pretty mighty programs here. So 6% of the jobs in the United States are STEM focused, but 75% of the jobs that you'll use will require some STEM skill in some way or another. What we have here is, we have the usual STEM focused fields like accounting, but we all biological and environmental sciences, but we also have related towards manufacturing. We have automotive technology. We have computer application specialists, electromechanical technology, information technology, wind energy technology, which is one of the fastest growing fields in the state of West Virginia. In technical studies through our workforce program, which concentrates on certificates and mostly skills and trades, we have pharmacy tech, nursing, which is rooted in the fundamentals. Everything that is related to STEM has nursing. And then, of course, we have other trade related skills like welding, which would, I guess fall under the category of engineering. And of course, what programs that we lack, of course, we do have the classes that go with STEM related fields, such as, the usual biology, chemistry, psychology, and economics. And we even have technical writing. And from what I understand, the teacher is incredibly wonderful and seriously funny and extremely good looking too. So, of course, it's me, but the STEM fields are something that's definitely something that needs to have focus. For opportunities for high school students here at this very small school, we do have an IT internship. We do offer a business management internship. We offer an accounting internship and an administrative support technology internship. As far as financial aid goes, financial aid for workforce related programs, we can only offer West Virginia HEAPS, which is for part-time students only. However, there is financial aid available for any that would go through an Associate of Arts, Associate of Science, or Associate of Applied Science in one of the STEM-related programs that we have. Now, West Virginia also has a program called West Virginia Invests. And what this is for our school as a community college. If you are in one of these fields that qualify and usually it's the STEM fields, your college is paid for. Students really only have to do one drug test and then 2 hours of community service. And West Virginia Invest picks up the tab. And I really don't have a whole lot other than that. I'm pretty quick. I throw a whole bunch of information out in the shortest period of time possible.
Thank you, Brian. That was very thorough. Seems like agriculture, since your school is rural, seems to be a very popular program.
Normally it would be, I guess, because of the past few years of dealing with COVID and everything. I think everybody that's in education has been feeling the pinch as far as enrollment and things like that. But we're getting our agricultural programs a little further up off the ground, and it's something that around here is always going to be in demand.
Right, absolutely. Cool, thank you so much, Brian. We're going to do a Q&A, so all of our panelists. I will just go in order. So I guess I'll start with Mia, since you went first, and then I'll just continue on to the order that we had everyone else presenting. So Mia, I know you touched on that, your journey and how you came to start your own manufacturing business. What was the most challenging part of that? I know that you said you had purchased a previously existing business, but you also had to source for funding. But can you speak more on the challenges you experienced?
The first year after my acquisition, I acquired the company during COVID. And so our main demand driver is elective surgery. So the company was already impacted by that. But on top of that, month one, there was a supply chain crisis. And so we've had challenges getting product from Vietnam. And so, trying to be innovative, utilizing my background in supply chain and operations to navigate the increasing transit times and really getting the company to have the right amount of inventory, all those things in order to, ensure that we can still service our customers and have the right product on our shelves. So that was one of the major challenges that we've been facing over the past year.
Yeah, and since you are working in the healthcare and healthcare manufacturing, how would you say that your business has been affected with COVID or by COVID? Do you feel like you all would, I guess, manufacture more, or has it helped your business?
No, so it has hurt us actually. So again, our demand driver, or what's driving our sales, are elective surgeries. And when there's more COVID patients, there's less availability of elective surgeries. And that's also hurting hospitals as well from their profitability. And so as a result, our products are used in the operating room mainly. And so less surgeries means less revenue. So we've seen an impact with that. But we've also, I think there was a major dip in 2020, but we've been slowly kind of going back up in 2021 and 22. So it's recovering.
That makes sense. I would have thought it'd be the other way. I'm like, oh, more people are in the hospital, you need more healthcare product, but
Yeah.
that definitely
But
makes
COVID
sense.
didn't require surgery, so which is good.
Yeah.
But if there were more surgeries, we definitely would have benefited.
Yeah, thank you. That makes sense. Roger, so at the end of your presentation, you had a image that talks about all the different branches that are included in manufacturing. Can you speak on, or if you know, what industry, particular manufacturing, seems to be the most economical, or where we're trending towards? Or if there's not one in particular, is there like a kind of scale, top three?
Yeah, I mean, typically the community colleges around here are teaching sort of hands-on CNC type manufacturing skills and how to measure things and how to make things to a tolerance. The big gap we're finding is actually finding skills that can bring manufacturing process expertise, like Six Sigma, quality control, supply chain logistics type of experience. That doesn't seem to be readily available. So what's happening, manufacturers are poaching from each other, which is not really the solution. The solution is to create pathways with those skill sets.
And I know that Mia, you touched on Six Sigma too, but in case high school students don't really know what that is, can either of you explain what Six Sigma is and how it's used in manufacturing? And then also, what are the steps taken to acquire Six Sigma certification?
You're asking me? Okay.
You, Roger, or
Okay.
Mia, whichever one of you wants
Sure.
to explain, or maybe you can flip the question.
Well, I'm a former lecturer in statistics, okay, so I got a little bit of background. Essentially, it's a method of sampling the production tolerances of anything you're making and keeping those tolerances within a certain standard deviation. So you set those deviations up to make sure whatever you're making, whether it's going into aerospace or automotive, will always fit. So it's a guaranteed replacement part that always fits. And some of the nonprofit work I've done in Africa and in Asia, a lot of the parts were made sort of by artisans. They made very well, but they didn't follow a kind of regime of knowing the standards and meeting those standards. So when parts needed replaced, they often didn't fit. So Six Sigma is a discipline which pretty much ensures whatever you make will fit.
Yeah. I think to add to that, you added lean into that. So lean in a manufacturing setting or any setting actually is to eliminate waste, right? So we always hear like the fastest way from point A to point B is a straight line, right? And sometimes we go in the circle or round and round, but the idea is if you're trying to go from one point to another, it'd be a process. Even submitting paperwork, or think about applying to school, that you find the most efficient process and you eliminate the time or the wasted steps or energy to try to get from point A to point B. And that's kind of how lean and Six Sigma has come together, because Six Sigma wants to make sure, and I always use the analogy for kind of similar to Roger, like you're a vehicle, right? You want to make sure your cell phone, you want to make sure that it's not going to blow up on you, right? And then you got to make sure all the parts in it are great and are working together. And so that means all the manufacturers that manufacture those parts have to be pristine and no defects. And so the idea is reducing the defects. And to do that, you reduce the waste. And so that's how kind of Lean Six Sigma. The process of certification is learning about the methodologies. And then they have a right now, I even have individuals at my company that are getting their different certifications. So you can go online and take courses. And they have, I think it's a white belt, a yellow belt, a green belt. I think they're somewhere in between, and then a black belt, and then you can be a master black belt, which means you're basically a teacher and master.
Like karate.
Yeah, just like karate, right? But I think that in any job that you do, especially in STEM, but even outside of manufacturing and outside of science, Six Sigma and especially lean methodology is so critical. And you can even use it in your own personal life, right? So I'm definitely a proponent of it. And it's kind of under the umbrella of continuous improvement if people want to research that.
Thank you, Roger and Mia. I understand what Six Sigma is better now myself. All right, thank you both. Danielle, thank you again for telling us about West Virginia University. What you went through the slide about STEM programs. What seems to be, if you know this, if you can answer, this most popular STEM program that students tend to go into at West Virginia University?
So by and large, engineering, because it makes up so many different disciplines, we see the largest number probably gravitating towards that field just on a pure percentage basis. But we're definitely seeing an uptick in fields like neuroscience. We're really seeing students become interested in that field. Nationwide, biochemistry is becoming one of the most popular pre-med programs. So we're definitely seeing students taking an interest in that field. But then I would say across the board, we have it spread pretty equally then, especially when you get into some of those very specialized, like for example, an immunology and medical microbiology program. You're never going to see massive numbers, flocking to that program, but it's very strong, and students are able to get that hands-on learning. I did see a question in the chat, if you don't mind, or do you want me to wait until?
Go for it. You can read and answer it.
Okay, so the question was, how is your school working with secondary schools to better prepare and pique students' interest in the STEM fields? Something that we really believe strongly is that we need to get students interested in STEM early on, and maybe not even so much piquing their interest, but developing their interest, especially young girls, just making sure that they know that there are opportunities for them in the STEM fields and to continue to pursue that if that is an interest for them. And so something that we offer, I'll put the link into the chat here, but we do offer a variety of summer camps for students. Engineering, it actually goes as young as the elementary level. So again, students, it really just cultivating that. We fully understand that STEM is not for every student. There are a lot of fantastic students out there that gravitate more towards the social sciences and the fine arts. But I think that the STEM really just being able to cultivate and encourage students who have those interests to pursue them. So the link that I put there is to all of our summer camps, but specifically for STEM, you'll notice that we have a forensic science summer camp. We have a program called the Brain Camp that's for students entering 11th and 12th. We have then those engineering challenge camps that are everything from elementary to high school levels.
Thank you. That is super helpful. I'm sure that students will be interested in opportunities for the summer, always looking for something to do. And besides programs, does your university offer any STEM-related certifications for students?
So we do have different certifications. So the website that I listed for the academic programs, you can actually filter it. So for program type, you would actually type in just certificate, and it offers all the different levels. Now, some are graduate certificates, but this is but that gives you all the certificates and certifications that you can get at the university as well.
Thank you. We'll definitely share that. Yes, awesome. Thank you, Danielle. So Brian, I know you touched on your school offering a lot of different certifications that students can complete. Do you know how quickly those certifications can be completed? Like a length of time?
For the most part, most of our certifications can be done in 1 year. We do have some in the health fields that can be completed, certifications can be completed in a few months. But for the most part, everything is in about 1 year.
All right. I don't think we have any more questions. This was really great. Let me share my screen so I can touch on the last slide. All right. So I do want to thank once again all of our wonderful panelists for speaking with us today. This video is recorded, and we will also share this with our West Virginia teachers and their students. We hope that everybody finds it helpful and just learns more about the field of manufacturing. So once again, thank you to our panelists. Thank you to all of our sponsors, the sponsors, in particular, the Benedum Foundation, who is helping us with today's event. So with that, I will bring this event to a close. Have a wonderful day, everybody. Thank you again for our panelists.
Thank you.
Thank you.
You.